In this video, we are going to be discussing dimensional analysis. Dimensional analysis is basically a process that converts between measurements. So if you have teaspoons and you want to know how many teaspoons are in some amount of cups, so forth and so on, dimensional analysis makes that possible. It gives us a process to convert between those two measurements. And when we're converting between those two measurements, we use what's called a conversion factor. And a conversion factor is going to be a rate. And our rate is going to be where the quantities are actually equal to one another. So if you remember from our common conversions, 12 inches equals 1 foot. So these two things are said to be equivalent of one another. So we use this conversion factor and we're going to multiply it by some number to be able to change between units. The reason why this equality is so important is because anything divided by itself is just 1. So this is basically just the number 1 just looks a little bit different. And when we multiply something by 1, we don't actually change it. It stays the exact same. It just becomes, it looks different, but it's still the same number. So, an example. We have a fast sprinter and they can run 100 yards in approximately 10 seconds. And we want to convert that 100 yards into miles. So we have an uncommon conversion between yards and miles. So anytime we have some uncommon conversion, it will typically be given to you as a hint or a you should know this piece of knowledge. So the 10 seconds is really just there to kind of throw you off because all we care about is changing 100 yards into miles. So to do that, we are going to do basically what's called a box method. This box method is more of an organizational tool to help you with dimensional analysis. And dimensional analysis is extremely important for all math from this point on. It's used in chemistry, it's used in physics, so it's also in your science classes. So being able to stay organized with dimensional analysis is going to be key. So that's why I'm going to teach you this organization method. So here I'm going to just draw some kind of rectangle. I'm going to split that rectangle in half horizontally. So basically what I'm doing is I have a place for a numerator and a place for a denominator. So I'm going to put this 100 yards and notice that I'm putting the unit there. So this right here, I'm going to close this box, is the 100 yards. So again, I'm making sure I write the words yards inside of there. So now what I'm going to do is I'm going to take the common conversion, so this conversion factor, that's 1760 yards is 1 mile. I'm trying to get rid of yards. So because I'm trying to get rid of yards, I'm going to make sure I put the word yards in the denominator because my yards is currently in the numerator. And those would cancel. You can almost treat these units as their variables. So this x divided by this x are just going to cancel. So that means that I'm going to be putting my mile in the numerator. So we know that 1 mile equals 1,760 yards. So here we have this conversion factor. So this was our start. This was my conversion factor. And again, the important piece is that whatever I started with, so since yards is in the numerator, yards needs to be in the denominator for my conversion factor so they would actually cancel out. So all I have to do now is basically just multiply. So I can treat these little crosses like they are multiplication. So the units of yards are going to cancel away because it's basically like x over x, which would just be 1, so it cancels. And I can multiply 100 times this 1 miles, so I end up with 100 times 1, which is 100 miles, divided by this 1760. So all I have to do now is just put this 100 divided by 1760 into a calculator and round it to the nearest hundredth. So 100 divided by 1760 gives me 0.06 miles. So this is dimensional analysis, where we are going from the unit of yards and we are changing it to the unit of miles. So what this is saying is, hey, 100 yards actually equals 0.06 miles. So let's look at another problem. So a cheetah can run at a rate of 60 miles per hour in short bursts. What is the speed in feet per minute? So again, I'm going to start off with a rectangle. You may have to lengthen it if problems get longer, but it's okay. So I'm going to split that rectangle. So here, this right here is a rate. So it is a unit rate. So because this is a unit rate, the 60 miles per hour, there is a 1 right here for this hour. And this per means your division. So when I'm writing out this, I'm going to put 60 miles in the numerator and 1 hour in the denominator. So again, I'm writing down my units next to each thing. And since 60 miles is in the numerator divided by this 1 hour, I'm putting the 1 hour in the denominator. So the end goal, what I'm trying to get to is I'm trying to get to feet per minute. So this is what I want my units to look like at the very end of the problem. So I'm going to take one at a time. So here is my start. So I see that I need to try to get rid of miles and I need to try to change miles into feet. Well, we know that conversion, that is a common conversion, and that is one of the ones I highlighted and starred. So again, since miles is currently in the numerator, I'm going to put miles in the denominator, and feet, because that's what I want to go to, is in the numerator. So again, notice that they're in opposite locations, a numerator and a denominator, and notice that my feet is in the numerator, and that's exactly what I want my final answer to be. So I'm in a good place right now by just looking at the units, because my miles will all already cancel out, so they're going to just disappear. And I need to write this conversion. I know that 1 mile equals 5,280 feet. All right, so we now got rid of the miles and we're going to have our feet. So the next thing is I need to get rid of hours and change that into minutes. So I actually need to multiply by another conversion factor. So again, basically each of these is just going to be multiplication. So now I'm looking at this hours. And if you notice, hours is currently in my denominator, so I need my conversion factor to have hours in the numerator. And I'm trying to go to minutes. So again, notice that now we have the hours are in the opposite location, so they're going to cancel. And my unit left over is minutes, which is in the denominator, which is exactly what I want in my final answer. So as of right now, my units match perfectly. Notice how all the highlighted ones are going to cancel, and I'm left with the non-highlighted ones, which is what I want as my final thing. So I just need to use that common factor where 1 hour equals 60 minutes. So in 1 hour, there are 60 minutes. So here, I'm just going to put what it's equal to. So notice that the miles are going to cancel, the hours are going to cancel, so I'm left with feet in the numerator, because that's all that is left right here. And then I'm left with minutes in my denominator. So I haven't even done any math with the numbers yet, but I can already see that my units match my final answer. That is why dimensional analysis, when you are organized, should be extremely straightforward. So we can go and actually do this math now. One thing is I see this 60 and this 60 will actually cancel out, so I don't have to do that much work. And 1 times 1 is just 1, and 5,280 times 1 is just 5,280. So that means that there are 5,280 feet per minute in 60 miles per hour. So again, set up some kind of rectangle where you clearly can cross out all of your units and get to the final answer. So how about you guys try this problem? So a cyclist can travel 56 miles in 4 hours. And I want you to convert that to feet per second. So feet per second, and round it to the nearest tenth. So you may need to do more than 2 conversion factors if you don't know how to get from hours to seconds. You may need to go to hours to minutes, then minutes to seconds. So you should have gotten 13.2 feet per second. So they are traveling 13.2 feet per second. So pretty much more than double my height per second. That's how quick this cyclist is going.